kept in mind while using units. The symbol of unit, named after a scientific, has initial capital letters such as N for Newton. Second, compound prefix are not allowed. For example, may be written as IPF. Reduce random error. What is the reduced random error? Definition of reduced random error is that repeating the measurement several times and taking an average can reduce the effect of random error, are called random error. This is the definition of random error. Reduce systematic error. What is the reduced systematic error? The systematic error can be reduced by comparing the instrument with another which is known as to be more accurate and a correction factor is applied. How can we determine that uncertainty in time period? Question: how can we determine the uncertainty in time period? The uncertainty in the time period of a vibrating body is found by dividing the least count of timing device by the number of vibrations. This is the definition of determining uncertainty in time period. Name two major types of errors in measurement and also define them. Two names of major types of error in measurement and also define them. Write the difference between systematic and random error. Before this question, we read it. Differentiate between random error and systematic error. Also read. Write the main type of error. This is the main question. Write the name of type error. What is the type error? Major two types of errors in measurement are systematic error and random error. How can you access the uncertainty in the average value of many measurements? What is the value of measurement? Answer: the access the uncertainty, we find the definition of each measure's value from the average value. The mean deviation is the uncertainty in the average value. This is the value of measurement. How will you access the total uncertainty in case of power factor? Give an example. What is the power factor and give its example. Power factor: multiple the percentage uncertainty by the power. For example, volume of sphere is calculated by using V. If the radius of a small sphere is measured as 2.25 centimeter by a vernier calipers with least count 0.01 centimeter, this is the uncertainty by that power. What is the cause of random error and how can it be reduced? How can we reduce the random error? It is due to some unknown errors. Recording the measurement several times and talking an average can reduce the effect of random error. This is the definition and the example of random errors. What is the cause of systematic error? How can it be reduced? How can we reduce systematic error? And the definition of systematic error: it may occur due to zero error of instrument, poor calculation of instrument, or incorrect marketing, etc. This is the definition of systematic error. Next topic is significant and figures. What is the significant and their figures? Define significant figures. In any measurement, the accurately knows digits and the first default digits and significant called the significant figures. For example, as the example of significant figures, the number of significant figures in the measurement 2.59 centimeter are the example of significant figures. Using rule, is the zero significant or not? Explain. Question. What is the question? Question is the zero significant or not? Explain. A zero may or may not be significant. The following rules are used. A zero between two significant figures is itself significant. Number 2, zeros to the left of significant. Zero is it left of significant. Figures not significant. Number 3, in decimal fraction, zeros to the right of are significant. In decimal fractions of the left significant figures are not significant. How the next question? How the digit 5 it is insignificant will be rounded off. Question. I repeat the question. How the digit 5, if insignificant, will be rounded off. If the digit to the dropped is 5, if the digit dropped to the 5, the previous digit which is to be related to increase by 1 of it is odd and retained as such it is a even. This is the definition of insignificant will be rounded off. How many expected number of significant figures are in 8000 kg? I repeat the question. How many expected number of significant figures are in 8000 kg? Answer. In integers such as 8000 kg. In figures as such as 8000 kg, the number of significant 8000 kg or the number of significant zeros is determined by the accuracy of the measuring instrument. If the measuring scale has a least count of 1 kg, then there are 4 significant figures. As the least count of 1 kg, then there are 4 significant figures of instruments. Written the scientific notation as 8000 kg if the least count of the scale is 10 kg. Then the number of significant figure will be 3. Figure will be 3 written in scientific notation as 8.00 multiply 10 kg and so on. Next question is assessment of total uncertainty in the final result. In this topic, we study total uncertainty in the final result of timing experiment. Answer. The time of 20 vibrations recorded by stopwatch up to the 10th of a second in 40 seconds. What will be percentage uncertainty in a radius of a small sphere? This is most important question. I repeat the question. What will be the percentage uncertainty in a radius of a small sphere measured as 2.25 centimeter? Absolute uncertainty is equal to least count plus minus 0.01 centimeter percentage uncertainty is radius r is equal to 0.01 centimeter over 2.25 centimeter. How can the total uncertainty be found? The final results for